In today's session, we will be discussing about a topic from the module 3, 18CHE12. The chapter is fuel cells, and the topics which we are going to cover in the session is introduction to fuel cells and methanol oxygen fuel cells. The outcomes of the discussion could be listed as follows. After the session, the student would be able to define the term fuel cell and write the cell representation of a fuel cell, list advantages and disadvantages for the usage of fuel cell as an energy source, distinguish between storage cells and fuel cells, explain the construction and working of methanol oxygen fuel cell, write the reaction involved in methanol oxygen fuel cell, and list the application of methanol oxygen fuel cell. Before beginning with the concept fuel cells, let us now see the introduction for fuel cells. As we know, the entire world is suffering due to energy crisis, that is, due to the continuous consumption of conventional energy resources, the energy crisis problem have cropped up. So, one of the best alternative way to overcome the problem of energy crisis is going for the option of fuel cells. Often, the usage of fuel cell as a source of energy is also termed as fuel cell energy economy. For the current world, for the current market, fuel cells are considered as one of the best source of energy resources. In order to begin with, let us first define what are fuel cells. From the lower class discussion, the fuel cells definition and construction working of the primary fuel cell, that is hydrogen oxygen fuel cell, is you must be knowing. However, let us once again study the definition and continue for some advanced fuel cell construction and working discussion. So, fuel cells are defined as galvanic cells in which the chemical energy of the fuel supplied is directly converted to electrical energy. How the process is taking place is, it is by means of electrochemical process, and here the fuel get oxidized at the anode. So definition mainly contains 4 important points. The fuel cell are the example of galvanic cells. Second thing is, here chemical energy would be directly converted to electrical energy. It involves electrochemical processes, that is oxidation and reduction, and always the fuel must be supplied at the anode. So, by considering the definition, we can write a general cell representation for fuel cells as the fuel in contact with the anode, which would be in contact with an electrolyte. That will be in contact with the cathode, where the oxidant is supplied. In general, while we write as oxidant. Most of the time, oxidant supplied would be oxygen. Now let us go for advantages and disadvantages of the fuel cell. Any technology we adopt would be always having some advantages and limitations. So let us list or compile them together under 2 sections. So let us see first advantages of fuel cells. The very highlight point with the fuel cells is its very high efficiency for the energy conversion. Also, they are known for silent operation or less noise operation. Then, most of the time, whenever fuel cell works, the product would be carbon dioxide and water, which are considered to be less harmful, or else we can almost say the products of the reaction are almost no harm kind. Another benefit of using fuel cell is there is no necessary of charging process as like conventional cells we use. However, the system also have some limitations when we take it to the practical usage. Important point there is the cost of the power would be very high, in the sense whenever we construct a fuel cell, the electrodes which are employed are quite costlier. So automatically this cost will be added up for the production of power. So we say that cost of the power is high. Also, power output is moderate on observation. Then whenever any fuel we must supply to the fuel cell, it is always saved as a gas. Also an oxidant, that is oxygen, we need to store. These are always stored in tanks with very high pressure and it need to be continuously supplied. This is a practical problem for the working of a fuel cell. Then in order to have an appreciable voltage, that is for the practical applications, a battery of the fuel cell must be available. That is, fuel cells must be arranged in series in large number so as to have a better or great voltage output. So let us once distinguish between the conventional cells and the fuel cells. Conventional cells are nothing but the storage cells, or in common language we call them as batteries. Batteries are considered as one of the best way how the energy demand is met, and fuel cell is considered as the one of the modern technique where the energy demand is met. So as a part of curriculum we will be seeing here how the storage cells are different from the fuel cells. From the module 1, where the battery technology we have studied in detail, almost the fundamentals of the storage cells is covered up. So considering that particular topic, we can compare that with the fuel cell. So first and foremost difference which is observed is, in the batteries, reactants are the integral part of the cell. That is, anode, cathode and electrolyte are assembled in a system and it is kept in a can and ready for the use. However, when we construct a fuel cell, the reactants are supplied from outside and this process must be continuously maintained. Another major difference between them is batteries can store the chemical energy, whereas that cannot happen in the case of fuel cells. It produces the energy which must be consumed then and there. Also we can add another point that is about the products. Most of the time the batteries produce products which are considered to be less eco-friendly, or else we can almost say harmful to the living kind. Whereas fuel cell would produce the products which are almost eco-friendly and less harmful for the mankind. That is why fuel cells have added advantages over the batteries. Now as the part of our curriculum, let us now first see about methanol oxygen fuel cell. The picture presented there is the compact or assembled methanol oxygen fuel cell which is used in the industrial sector. This is a schematic representation of methanol oxygen fuel cell. Here we will be seeing the construction and the working part of the fuel cell in brief. Hydrogen oxygen fuel cell, as we have already studied, the similar concept could be employed here, where hydrogen is a fuel is now replaced by methanol as a fuel. Now let us have a deeper look into the diagrammatic representation of the fuel cell. The system is having an anode and a cathode, which is shown by the dark color, and it is shown that it is highly porous. Near the anode, always the fuel is supplied, that is methanol CH3OH. And near the cathode, it is always oxidant, that is oxygen is supplied. Left side top, oxygen is supplied, and from the bottom, the excess oxygen and the product water diffuses out. And the system is given with a carbon dioxide reservoir. The product carbon dioxide is removed out from the reservoir, that is both from the top and bottom of the fuel cell. The electrolyte used for this fuel cell is sulfuric acid, because we are discussing acid fuel cell. There is a possibility of usage of alkaline medium as well, but the curriculum restricts us for the discussion of acid electrolyte fuel cell. Near the cathode, if you can make out, there is a presence of a membrane which is shown by a dotted structure. This membrane is usually made up of polymeric material, and it is always situated near the cathode surface. Now let us see still deeper about the construction. Important 3 points here: the anode, cathode and the electrolyte. Anode is nothing but porous nickel sheet on which platinum and palladium catalyst is deposited. Similarly, the same nickel sheet in the porous condition could be taken as cathode when silver catalyst is deposited on the same. And electrolyte, as we have seen in the previous diagram, is nothing but sulfuric acid. And a line to be added here, that is the role of membrane which we place near the cathode. Now let us go back to the previous diagram to understand the role. From the right hand side of the diagram, if we observe, near the anode we supply the methanol. Imagine there is no membrane near the cathode. What is the possibility? The methanol which we supply at the anode may diffuse directly to the cathode, and it is a hydrocarbon, so directly may get oxidized. That is why we say that a polymer membrane is placed near the cathode, which would stop the diffusion, or else it stops the direct oxidation of the fuel. If direct oxidation of the fuel takes place, we would miss the electrochemical reaction where the electric energy is produced. Now let us see how the fuel cell helps us to produce the electric energy. The electrochemical process is explained here as oxidation and reduction reaction and the overall reaction. At anode, it is always oxidation process. So we supply fuel methanol CH3OH at the anode, which undergoes oxidation to give carbon dioxide with the liberation of proton and electron as per equation shown at anode surface. And these electrons liberated at the anode would migrate towards the cathode. We supply oxygen at cathode, which consumes the proton and electron and gets changed to water molecules. So when you write an overall reaction, it is methanol oxygen fuel cell. So it is methanol plus oxygen would give carbon dioxide and water. They are the products of any oxidation of the hydrocarbon. But what to be remembered is the oxidation of the methanol takes place via electrochemical reactions liberating the electron. The electrons from the anode surface would migrate to cathode. In the external circuit, when it flows, we draw it out as a current. Also, point to be remembered is methanol oxygen fuel cell is often termed as 6 electron system. That is, whenever methanol undergoes oxidation, it releases 6 electron, and that will be consumed towards the cathode. So it is easy to remember the reaction by remembering that every oxidation of methanol would liberate 6 protons and 6 electrons, which would be consumed at the cathode from the oxygen molecules. This is the diagrammatic representation how the electrochemical reaction takes place in methanol oxygen fuel cell. So here near the anode we supply the methanol. Excess carbon dioxide is coming out at the left bottom shown in yellow arrow-headed lines. The electron from the anode surface would be migrating towards the cathode shown by red color arrow-headed marks. The electrolyte taken is H2SO4 represented as H plus present in the middle, and the product, another product at the cathode surface is water, which is taken out towards the right side, that is cathode, shown by blue arrow-headed mark. Similarly, supply of the oxidant at the cathode is also shown at the right top portion. So altogether this particular figure shows us the electrochemical reaction happening in a fuel cell. Now let us move to the last part of the discussion, that is applications of the fuel cell. Since the methanol oxygen fuel cell is known to produce small power output, it is used for the automobile industry but not for the very large scale to the smaller automobile sector. Then it is also used in the consumer goods which we use in our everyday life, like mobile phones, digital cameras or laptops. This is because fuel cell could be prepared in a compact size so that usage becomes quite easier. As an emerging application, methanol oxygen fuel cell find its role in military applications, that is for charging the batteries or else for tracking systems. So in the entire discussion we have seen the introduction to fuel cell, the advantages and limitations of the fuel cell as an energy economy, and the comparison between the storage cells and the fuel cell. As an example of working of fuel cell, we have seen the construction and working of methanol oxygen fuel cell with the applications of the same. Another fuel cell in the curriculum is solid oxide fuel cells, which will be taken up in the next session. Thank you.